To compare rational numbers, we again can plot points on the number line. The numbers farther to the right are larger, and the numbers farther to the left are less than or smaller. Again, we're always comparing to that 0 in the middle or comparing to the two numbers wherever we plot them. Where do rational numbers go on the number line? So the first thing we can do is we can see between which integers the rational numbers would go between. For example, our first number, negative 5.2, is going to be negative, so to the left of 0, and going to be somewhere in between negative 5 and negative 6. 1.25 is going to be positive, so to the right of 0, and somewhere in between 1 and 2. Negative 4 1/2 is going to be negative, so to the left of 0, and somewhere in between negative 4 and negative 5. Negative 2.5 is negative as well, so somewhere to the left of 0, in between the negative 2 and the negative 3. And 3 3/4 is positive, so to the right of 0, to the right of 3, in between 3 and 4. So when looking on the number line for rational numbers, the first thing is to see which or where in between what two integers the numbers belong between. We can put these numbers on the number line as well. Start with our integers, negative 1, positive 4, 0, 2, negative 8, negative 2, negative 4, 6, and negative 7 are all integers that go right above their unit on, or their tick mark on the number line. The other 4 we can now see again. Look, if positive 1.25 is going to be to the right of 0, somewhere between 1 and 2. So somewhere in between. Negative 2 1/2 is going to be somewhere to the left of 0 because it's negative, and somewhere in between negative 2 and 3. Negative 3.75 is going to be to the left of 0, somewhere between negative 3 and 4. And 3 2/3 is positive, somewhere to the right of 0, between 3 and 4. The largest number we can see is the number farthest to the right, which in this case is going to be 6. And the smallest is going to be the number farthest to the left, which we can see is negative 8. We can also place numbers even when we see that they are between two integers, such as negative 2 and 2. We can zoom in on our number line. So first, let's deal with our positive integers. The 2 to the right of 0. So that would be 7 over 8 and 7 over 10. We then need to compare the two to see which one would be closer to 1. Now, closer to 1 would be a fraction would be the same number over itself. For example, if the denominator was 8, 1 would be 8 over 8. And here 10 would be 10 over 10. Well, the numerator, 7 is extremely close to 8. 7 is closer to 8 than 7 is closer to 10. So 7 over 8 will be closer to 1 than 7 over 10 is closer to 1. Now let's look at our negatives. The first thing I see, or you should notice, is that we have a number that should be greater than negative 1 if reduced or written as a mixed number. Here, negative 4 over 3, the numerator is larger than the denominator, which means that this is larger than negative 1 or larger than a whole. So that can drag there. And now we need to compare again negative 4 over 5 between negative 2 over 3. Negative 4 over 5 is closer to negative 5 over 5 or 1. And negative 2 over 3 will go in our final box. We then have each number from least to greatest, with our smallest number being -4/3 and our largest number being 7/8. Sometimes you will be given fractions and decimals that you need to compare. It's usually easier to convert all fractions to decimals in order to compare them on a number line. To convert a fraction to a decimal, we're going to divide the numerator by the denominator. So in this case, we have a numerator of 3 and a denominator of 4. So we're dividing 3 and we're dividing it by the denominator of 4. And we can see the decimal equivalent, if we do our long division until we get a remainder of 0, is 0.75. So here, 3/4 equals the decimal 0.75. So in order to compare numbers, let's convert or make sure we see them in decimal form. So -2 1/2 is the same. If we divide 1 divided by 2 is -2.5. 1 divided by 4 is -2 and 2.5. Or -2.25, excuse me. So -2.5 is farther away from 0, so it's less than -2.25. -3 1/8, 1 divided by 8 is 0.125. So 3 1/8 is 3.125. Compared to 3.4, 1.125 is less than 4. So again, 3 1/8 will be less than 3.4. -6.7, a negative compared to a positive is always less than a positive. That one we don't even need to convert 6 1/2. That's always true if the signs are different. Here, -1/2 is the same as -0.5. 4 divided by 5, or -4/5 is -0.8. which is farther away from 0, so -1/2 is going to be greater than -4/5. Here, these are both in decimal form, so -8.75 and -8.25. -8.75 is farther from 0, so less than. A positive is always greater than a negative. Just like the case of number 5, we had 2 different signs, so it was easy to compare. Here, -10.2 is closer to 0 than -15.4, so more to the right, so it is greater. 7/8, 7 divided by 8. For 1 and 7/8 will give us 1.875. which is farther from 0 than 1.78, so it will be less than 1.78. 2 1/3, 1/3 is 0.3 repeating, so 2.3 repeating. 2 1/2 is 2.5, so 2.5 is farther away from 0. So we will have that 2 1/3 is greater than 2 1/2. And finally, we have -0.2 and -5.4. -5.4 is farther from 0. -0.2 is closer, so it will be greater than -5.4. Again, always convert your fractions to a decimal and see which is closer to 0 to see which is larger, or which one's farther away from 0 to see which one is smaller.